Hi everyone, welcome back to the new video. Hope you all are doing well. And this video is actually requested. I noticed that a lot of you are interested in post-message DOM XSS, and because I also found this bug in one of my recent targets, you guys are curious, okay, how to find this bug while bug bounty hunting and what post-message actually is. So we're gonna walk through all of that in this video. So before getting into it, hit the subscribe button if you haven't yet, because we are on the road to 50,000 subscribers. I would really appreciate that. Okay, so I actually created a very realistic lab to show you this process. Let me start this. Python server.py. And this is in my local host. Port 8080 shop.html. So this is how it looks like. I think it looks pretty cute. And the name of the website is Naughty Things, and it basically sells handmade keychains. Okay, as you can see, I really like Sakura Petal. Anyways, so I actually choose this type of application because the application I found DOM XSS in was actually similar to this. It was an e-commerce application selling products and stuff, and I was able to extract all the session cookies related to that website. So it really much replicates that. Anyways, over here you can also notice that there is a login button. So when you click on login and create an account, you will get your session cookies as well. Okay, so let's click on login. Okay, and we are logged in. As you can see my name over here. Now let's go to inspect and let's go to storage. Let me increase the size so you can see it properly. As you can see here, there are a number of cookies. Where did it go? Yeah, auth token, card token, and guest ID, language session ID, multiple session cookies. This is how a real application actually looks like. When you are logged into an application, you're assigned with multiple cookies. And as you can see, this is looking like a JWT token, as you can see, and it really much replicates the real application. Anyways, so the goal of this challenge is to get these session cookies to attacker's server, basically extract them by exploiting DOM, postMessage DOM XSS. So first, let's talk about DOM XSS. So let's see what DOM XSS is. Obviously, you can read about it in PostSwigger as well. Just want to give you a little idea. It's a client-side security vulnerability that occurs when a web application processes user-controllable data. It means any data that you provide through a search bar, through a comment section, or any other data, or anything that is going into the stores, and then passes it to an unsafe function like sync in a way that executes malicious JavaScript. A sync is basically a function that executes JavaScript code. So your data shouldn't be going in a sync without proper validation. If it's going without proper validation, it means you can also inject JavaScript code, and sync will do what it usually does. It just executes code. That's what its job is. There is nothing wrong with that, but obviously the wrong thing here is implementation. Now here are some examples of sources. We have document.url. So if there is something you're providing in the URL parameter, then that will be a source. And here are a few examples of things. As you know, eval inner HTML, that basically executes JavaScript or render HTML if they receive a malicious input. Now let's go back to this cute website. Okay, so looking at this, you will think, what could be vulnerable here? We don't see any search input here or anything where we can provide user input. Exactly. That's the beauty of DOM XSS. You cannot find it. If you look at the website like this, you will think, okay, there might be nothing over here, and you'll just move on. But if you look at the source code, let me just click on inspect and go to debugger. Okay, there's some error. Let's just reload it. Okay, now it's working fine. Cool. So this is the code for shop.html, and this is simple CSS code, but obviously when you look in the real application, you will see a separate CSS file here. But this is demo lab, so we have everything JavaScript, HTML, CSS all in one file. Anyways, we will scroll to the bottom, and over here we can see some HTML code. Okay, let's go a bit more down. Okay, so we have this window.add event listener, and we have some few lines of code over here. Document.get element by ID. It's trying to fetch element that has name promo banner. So if I search promo banner, yeah, so this is the element, div element that has ID of promo banner, and it's trying to interact with this. Okay, now let's go back to that vulnerable code. Okay, before I explain this code, I forgot to explain postMessage. So window.postMessage is a browser API that lets two different windows or frames communicate with each other even if they are on different origins. So as you know about same origin policy, where one origin can interact with another origin only if they are same. They're not allowed to interact with cross origin for security purposes, and that's why CORS also came into picture. So origin A can interact with origin B for sharing data. But you can also do that using postMessage, and that allows two iframes to communicate from different origins. This is a useful feature actually. For example, if you have done online shopping, you might have seen payment widgets. These are actually iframes, or any type of customization that requires iframe, you will see that often. These are basically simple part of any web application. And they have a postMessage listener behind them for interacting with those iframes. So that's a pretty common feature, but if this is not implemented properly, DOM XSS, postMessage DOM XSS can happen. Now, postMessage DOM XSS happens when a page listens for messages and takes whatever data arrives and drops it into a dangerous sink. In normal DOM XSS, the data comes from a source, but in postMessage DOM XSS, the data come from a postMessage listener. You're getting the point? And the end result is same. It goes into a dangerous sink like inner HTML eval or document.write. In this case, we have inner.html. So over here, the page is basically listening for any message to this window. When a message arrives, it takes e.data, whatever the sender passed, and writes it directly into the promo banner, that div tag we saw earlier, using inner.html sync. And why it's vulnerable? First, there is no origin check. As you can see, there is no validation of origin, and the code never looks at e.origin, which means it will accept messages from literally any window or iframe. Second is inner HTML parses and renders whatever string you give it as actual HTML. So if the string contains an XSS payload, the browser treats that as real HTML element and executes the on-error handler, like simple XSS payload that usually happens. No need to explain that. And that's why this whole code, this section is vulnerable. So when you're looking for postMessage DOM XSS, you can look for keywords in the JS files like add event listener, or this message. You can look for this whole string as well. You can look for postMessage keyword or e.data, event.data, similar to that. Okay, now that we know that this is vulnerable, let's exploit this. Over here, I have this file, poc.html. So as you can see, this is the exploit file, and we are going to deliver this to victim. So the moment victims loads this page in their browser where they're logged in into the vulnerable application, will get their session cookies that will lead to account takeover. As you can see, we are creating an iframe here, and display is set to none. It means it's hidden. The victim will not see it. And here's the actual attack. iframe.contentWindow.postMessage is a reference to the window object inside the iframe the shops window, and it calls the post message on it by sending a message directly to that window. And then we have the asterisk symbol here, means we are not specifying a target origin, so it goes through regardless. And as you can see, this is our payload imgsrcx, and since there is no image with x value, we will get an error pop up and it will execute this JavaScript code, basically extracting the cookies and sending it to us. Now, there could be different variations of this. I haven't provided the collaborator URL or interact SSH client URL to extract the cookies, but when I exploited the postMessage DOM XSS, I actually did that. I have shared the flow and what the bug was about in my members only video, so if you're interested in that, you can watch it from the I button, and you will also get access to different videos where I did live hunting and analysis in real targets. So yeah, anyways, in this case, what we are doing is simply we are taking the cookies and displaying it in the same page, which is poc.html. Okay, let's close it. And now we are going to send this. Basically, to send this to a victim, you obviously have to host it in a particular domain, but in bug bounty hunting, you don't have to do that. You can simply just do it from your local host, and that's enough POC in itself, as long as you are getting the cookies extracted. So let's open it up here. Localhost 8080, and name of the file is poc.html. So let's say we delivered this link to victim, okay? And victim is in the same browser, they opened it, and we have stolen cookies here, but we don't see anything somehow. Okay, now we see it. So these are the cookies extracted over here, and all of them. This is pretty similar to what I did in that bug. I was able to show the cookies in the UI just like this, and I was also able to get those cookies in my out-of-band interaction tools. I used interact SSH. So yeah, it was pretty cool actually. So that's how we exploit postMessage DOM XSS. I hope you found this useful and you got some insights from this. Let me know your thoughts in the comment section. Thank you so much for watching, and I'll see you in the next one.